Okay. So very good afternoon to all. Today in data analytics assignment number 2, we are going to talk about fitting of normal distribution and Poisson distribution for two types of data. And for this particular problem, of course, as it was demonstrated earlier, I'll be giving you the steps also. We can test through the goodness of fit also. We are going to do it here, but parallel to that, it is very important that you go through the PPTs as well as the session links which were given to you in the last week. Because if you really want to understand the concept, you have to go through those particular PPTs. Okay? So now let us start with this. Okay? So again, how you are going to do this particular practical, I'll tell it to you at a later stage. Okay? You will do it in Excel itself, but the problems which are given to you are going to be different. Okay? They will immediately after this session, they will immediately be in your Google Classroom, okay, or on your through your mail. Okay. Now, this is the problem which is given to you, okay, which has a lower class and a higher class. That means it has an interval with I is equal to 70. This is the previous problem itself, which we had solved it for mean, median, and mode. The same problem. Okay? And for the same problem now, we will be fitting a normal distribution. We are trying to fit a normal distribution, and we will check through chi-square test whether this distribution is good. I mean, is it a good fit? Okay. So that's what we are going to do. So what we will do first is we will see the data and we will see the steps parallel. Similar to the previous Excel sheet, this Excel sheet also contains the steps, okay, as well as the color coding, so that it will become easy for you to understand. Okay. Now, just check out here. Okay. So first you have the lower class with you, the higher class with you, that is the interval, and you have the frequency which is given for you. Now this, if I'm not wrong, this was a SC problem which was given to some division in SNP. Okay. Now in the last practical or in the assignment, you have also calculated the mean. You have also calculated the sigma, that is standard deviation. Okay. Now we will consider here the level of significance as 0.05. You may consider it as 0.01 also, but generally for such type of problems, universally it's accepted that 0.05 is more than sufficient. Okay. If you require more precision, then you can go for 0.0. Okay. So now first what we will do is we will first try to fit the curve, the distribution. So for fitting up the curve or for fitting up the normal distribution, your objective is to find the expected frequency. Okay. Now this is nothing but with reference to the area method of fitting the normal distribution. Okay. Now this is the reason why I told you that you have to go through those PPTs and the sessions. Okay. So as I said, this is nothing but the area method of fitting your normal distribution. Okay. So let us see what the steps are. Now the steps for the first one is to find out X. What is X? X is nothing but, as you can see here, the color coding, X minus mean. X is nothing but your frequency. No, X is nothing but your lower class. Correct? This the capital X minus the mean. Okay. So as you can see here, A4 minus 375.2822,581. Now 375.2822,581. This is your mean which you have calculated earlier. Okay. And A4 is nothing but your lower class. Okay. So you are going to find out X. Ata, if you can recall what we did in the last practical also, or in the last assignment also, let me demonstrate it to you here. So this will be, since this is Excel, okay, when you do the mathematical calculations, it should first start with is equal to, okay, and the lower class, that is A4 minus the mean. Now you cannot just click here the mean, which is at B17 cell. The reason being, if you drag it down, then this cell is also going to drag down. If you can see my cursor. And so you cannot do that. And since mean is a value which is fixed, so you can give the fixed value. There is another method also, which you can keep the number as it is by adding dollar sign in the beginning and in the end also. Okay, you can do that also, so that 375 as a value does not change anywhere. It will remain the same. Okay, but I prefer generally this one. Okay? So enter. This I'm just demonstrating what is done over here. Okay, and as said in the last session also, just go to this particular cell, go at the right hand side bottom corner, you can see a plus sign and just drag it down. Okay, you will get all the values. See if the values are the same. Yes, they are the same. Okay, now so you got the small x. Now next in the step 2, you are going to calculate x upon sigma. Okay, now x upon sigma means what? Now you have calculated already x. Okay, okay, here it should be small x. I think that will be good. Okay, so x, now I've shown you the this thing here. You can just go to the bar and you can click over here. You can see which cells are being selected. So x, that is E4 divided by sigma. What is sigma? Sigma is nothing but given over here, which you have calculated in the last practical itself. Okay, so 149.7508,716. Okay, just enter the formula here and just drag it down. Okay, so you will get this answer. Now, in the third part, what I have done in here is that now if you see in this particular column, you have more than 2 decimal places. Okay, so I have just concised this to 2 decimal places because I now need to learn, or I need to find out the area through the this particular table, which is areas of standard normal distribution table. And so 2 decimal places are required. So what I will do, what I can do here is I will demonstrate this over here so that it will become easy for you people. I'll just calculate it here. Now this is just a simple thing. Okay, now this is how it is. Column number F. So what I'll do is I'll select this particular column. I just want to make it 2 decimal places after the 2 decimal places. So what I can do is I can select, right click, go to format cells. Okay. Now once I go here, this particular block will pop up. Okay. Go to number. Okay. Now here you can select your number of decimal places. Okay. So you can have more than 2, 3, 4, whatever you want. Now, right now, I wanted to restrict it to 2 decimal places. So just 2 and say, okay. Now this is what I can get. So only 2 decimal places. Okay. So this particular column G, I will remove this particular part. Okay. This column G is nothing but the same column as F, only it has 2 decimal places. Okay. Now the next column, column number H, that is my next step, is area under the curve. Now, how to find this area under the curve? This area under the curve is to be found out from the table. Okay. Now, this particular table, areas of a standard normal distribution table, this table is available on net. It's available in any of the statistical book. Of course, I'll be sharing this particular present Excel sheet with you. And here also this sheet is available. Okay. So let me just blow this up a little so that we can see. Okay. Now you have to take this particular value x divided by sigma. Okay, and see what is the area under the curve. Now let us see how to check that. So what is the number? 2.11. So first go to Z. It's 2.1 over here. Can I draw it through my pen? Just check out. 9. Through my pen I can't draw it. Okay, anyways. So you can see here, here you can see it is 2.1. Okay, and it is 2.11. So 11 will be from the 2.1 and 0.01, so that it makes 2.11. So if you go here now, so 0.01 from here and 2.1 from here. So what is the value? 0.4826. And that is the area under the curve for x upon sigma as 2.11, 0.4826. Here you are going to neglect the negative signs. Okay. Now let me demonstrate to you one more. Okay. So 1.64. Now how to do that? 1.6 and then 4. Okay. So let us see here the z value 1.6 over here and 0.04. So if you go here, you can see here it is 0.4495. So that's what is my answer. Okay, so that's how you have to continue. I can demonstrate to you one more. Say it is 2.10. Now it is, how will you read this? It will be only 2.1 and 0. So it will be 0.00. So let us see here. So z value is 2.1 and 00. So 0.4821. That's how you have to calculate your. Now this calculation means you have to enter these values over here. Okay. Now keep this away for time being. Now this is the area under the curve. Okay. Now my next step talks about area of each class. Area of each class. So how to do that? Okay. So you have to calculate, or you have to add up, or you have to subtract the area under the curve for the first interval and the second interval. Okay. Now you have to subtract this when you have negative sign for x divided by sigma. Okay. So as you can see here, for this particular area of class, okay, how did I get this value? 0.0331, that is 0.4826 minus 0.4495. So that's how it is. Okay. Now let me go next. How will I get 0.0705? 0.4495 minus 0.379. So can I see that? Yes. I hope you people know how to do this particular operation in Excel. Okay. But this you will do only till when you get the negative sign of x by sigma. Now this is the rule of where when you are this is one of the rule for setting up your normal distribution or fitting of your normal distribution. Okay, so you have to go to those PPTs. It's very important. Okay, so now here you can see it's minus 0.24. So area under the curve, it will be plus now. Okay, plus which one? The previous one, that is for minus 0.24, and the next one. Okay, the place or the cell at which it is going to change the sign, you have to add them up. Okay, then goes the next one. Okay, now here you can again continue it with negative. Again you will subtract. Only for the first one, only when you are going to change the sign, you have to add up. Okay, now in the similar way you will continue. So in this particular area of class, when you put one particular operation, you just cannot drag it down. Okay, as you did for the previous one, because here you have to change this particular part and you have to subtract the previous one and the next one. Okay, now the next step is expected frequency. And how will you calculate that expected frequency? Area of each class into n. Now what is n? N is nothing but our total frequency. How did we calculate our total frequency? As we did in the last session also, sum is equal to C4 by C5. So you can see here it's highlighted. Okay, so the total expected n is 496. Okay, so just multiply I4 into 496. Okay, I hope you know this particular operation now. And now here you can drag it down. Now, once that is done, okay, now again this expected frequency, it's the same thing. This column number J, it is the same column or the same values as J. Only the thing is here I have converted it into one whole number, because frequency has to be whole number. It cannot be something like points. And so you will have to make it into a whole number. Okay, so that's what I did over here. You can write this down. Okay. Fine. So now this is what is fitting of your normal distribution. So you have your observed frequency, that is which is given in the problem. Okay, the one which I have highlighted right now. And this is what is the expected frequency which you have calculated. So that is what is normal distribution. Okay, fitting of normal distribution. But now the next part comes is you need to check whether this distribution is a correct fit or no. And to check this particular part, you have to do chi-square test or chi-square test. That is goodness of fit test. Okay. Now again, the rules of this goodness of fit test is that given in the sessions of chi-square test. So go through that, but the steps are anyways given over here. Okay. Now, when you test for hypothesis or when you test for goodness of fit, what is the first thing you do? You will mention the null and alternate hypothesis. Now, I have done it over here. You can see here. Now, I have my expected observed frequency, which I am naming it as OB. This frequency is nothing but the same thing which is given in the problem. Okay. Then you have expected frequency, as you can see, which I have highlighted right now. Now, this is the same one which I have calculated right now. This one. Okay. Now, before I calculate this as a part of my chi-square test, let me put up what is null hypothesis. So what my null hypothesis say in chi-square goodness of fit test, the null hypothesis assumes that there is no significant difference between the observed and the expected value. It means that the observed and the expected value will be equal. That is what is my null hypothesis. And of course, my alternate hypothesis will be that there is a significant difference between the observed and the expected value. There is a significant difference. Okay, that is what is my alternate hypothesis. Okay, now you have to test to whether you are going to accept the null hypothesis or you are going to reject the null hypothesis. Okay, through your test. Okay, chi-square test. Now, what is the first step for chi-square test? The first step for chi-square test is to find the summation of observed minus expected frequency square upon the expected frequency. Okay. Okay, this should be EF, whatever, the nomenclature can change. Okay, so that should be my formula. Now, from where I got this formula? Well, this is the basic formula for chi-square test. Okay, goodness of fit. So what I'll do is I will calculate OB minus OE square divided by OE. Okay, now I'll demonstrate it to you here. This demonstrate this particular part over here. This I've directly used the formula. If you want to break this into parts, calculate OB minus OE first, then square it, then divide it by OE. Well, that is also fine. Not a problem. Okay, but I'll demonstrate this over here. Okay, now if you can see here, okay, A22 minus B22, that is OB minus OE divide square root of B22. Okay. So let me demonstrate it over here, is equal to into bracket. What does it say? You have to just pay attention at this cell number F30, where I've given the formula. This one, the one which is highlighted in green. Okay. So OB is A22 minus expected frequency, that is B22, bracket closed, and I can give a square sign. Okay. Now this will just have the square. What I will do is I will put all this into one particular loop of bracket, not in a loop, in the bracket, and I will divide this whole thing by OE, that is your expected frequency, so that this whole formula can be fit into one particular cell and you don't have to unnecessarily going for more calculations, because that will add to more complexity. Okay, now I've got this, just go here, drag it down. Is it the same thing? Yes. Okay, so I got this particular formula, this particular cell. Now once I get this, I'll rub this off. Now what I will do, I will take a sum of all this. So what will be my formula here? Is equal to sum C22 by C34. So you can just check it out. Okay, so the cells are highlighted here. Now, once this is done, okay, my degrees of freedom will be n minus 1, as we all know. Now, how much is n over here? You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so n is 13 over here. Okay, so my degrees of freedom will be 13 minus 1, which is equal to 12. As you can see in this particular step also. Okay, so this is 13 minus 1, okay, and so it becomes 12. Okay, now find out the chi-square value. Now, to find out the chi-square value, you require the degrees of freedom and level of significance. So for this, you require the table of chi-square distribution. Again, this particular table of chi-square distribution, it is available in any of the books or on internet. It is available in this presentation, in this Excel sheet as well. So let us see what is the area of to the right of the critical value. So chi-square value from the table for 12 degrees of freedom and 0.05 as my significance value. Let me see. So here is my 12, and if I go here, it's from 0.05, this is my chi-square value, which is 21.026. Okay, so I'll just write it here, 21.026, or you can write it as 21.03. Okay, now once this value you get it from the table, you can calculate the p value also. Of course, right now, p value is not taught to you in the class, nor we had done this in SNP, so we will keep it as it is. Okay, but nevertheless, you can go ahead and you can compare this particular value which you have got through the table and the calculated chi-square value. Okay, so what is the calculated chi-square value? It is 22.86673, which you have calculated here. And from the table, how much is your value? 21.03. So it says that now you have to come to the decision that the calculated chi-square value, that is 22.86, it's greater than the table value. And so thus the fit of equal proportions is not good enough. It means that the observed frequency and expected frequency, they have quite a different values. They are not significant. There is some difference. Okay, so this is not a very good fit. That is what is a normal fitting of a normal distribution and checking whether it is a fit or no through chi-square test, that is goodness of fit. So these things you have to do for normal distribution fitting. Okay, now this is the first problem. Now let us go for the second one, in which we are going to fit Poisson distribution. Okay. Now the earlier one was normal distribution. Now we will go for Poisson. Now for Poisson distribution, we have tried with some other type of data. So just check out with this data. Again, let me mention it that you have to go through the PPTs earlier, which is given to you earlier. Okay. And the sessions, of course. Okay. Now for fitting of Poisson distribution, again, you have a series of steps. These steps are already given over here. Okay. An extract of a particular slide where it has explained through a problem, it has been explained how to fit a Poisson distribution. I've kept it here for my reference as well. And of course, for your reference as well. Okay. So let us see now. So what is the data given to you? Now, this data is also a real data, which is about the number of years and the number of minor injuries which have happened. So in some road accidents, actually. Okay. So now this is what is the data given to you. Let me put this data into a proper format. Okay. So the years are from 2002 to 2011. So let me treat this year as year number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And number of injuries, the data which is given to you. Now what I will calculate here is f into x. Now if you see this particular, go through those PPTs and see the steps, you have to first calculate m is equal to f summation fx upon n. Okay, and then you have to calculate the further points. Now for doing that, you first need to calculate f into x. Okay, so what is x? X is nothing but the number of years, which is 0 to 9 respectively. You have frequency f, which is nothing but number of minor injuries. So what will you do? Let me demonstrate it over here. Is equal to year into the number of injuries. So just drag it down, and this is how you get this particular form column f into x. Okay, so let me just rub this off. So now you got fx. Now what is n? Again, n is nothing but the total amount of frequency. So how will I get that? Is equal to sum f3 by f2. So from here to here. Okay, the same commands which you used earlier. Okay. Then of course this is for the year as well, the sum of the years. Okay. So now you got x, you got summation fx. Okay, summation fx पण आपण काढू शकतो. Okay. Now n, as we said, we calculated it over here 1100969, and m. Now how to calculate m? Summation fx upon n. The fx is over here, so let me demonstrate it over here. Fx upon n. N is how much? 1100969. So it is 5.003413. Is it the same thing? Yes. So I got fx upon n. Okay. Now once this is got, now I have to calculate p0. Okay, which is e raised to minus m. Okay. Now you can see here in the steps also it is given step number 6. P0 is equal to 0 is equal to e raised to p0 actually is equal to e raised to minus m. This should be e raised to minus m. Okay. So I've calculated here directly. Okay, let me demonstrate this to you. Okay. Now how much is e? To measure, if you try to write it like this, e raised to minus, then this will go wrong. Okay, you have to find the value of e. The value of e is 1 second, I'll just confirm the further part. 2.7187. 2.7187. Okay, now this particular value, of course, you'll get it on the net also. It is known to everybody, or you can go to help from here and you can get the values also. Not a problem. You can just give your query and it will give you the value. That way, Excel is very, very robust. It can help you in a lot of ways in which you can, which it can. Okay. So E value is there. Now what you will do? Simple. E raised to minus m. So I'll demonstrate this over here. Is equal to 2.7187. Again, raised to minus. Now what is m? 5.0034133.6. So 5.0034133.6. Enter, and that's what is my answer. Now you cannot drag it over here because all the values are going to be different. Calculations are going to be different. Okay. So now once this is got, now go to the next one. What is n? P0? P0 into n. We know how much is n. Okay. So let us calculate that. N, do we know that? Yes, 1100969. P0, do we know that? Yes, it is over here. So this will be equal to, I can do it directly here, P0 into 1100969. It is 73, it's 7.305. Okay. Now what is the next one? NP1, it will be NP0 into M. Okay. Now this will be, how much is here? M, 5.0034133.6. It's already given to you. Okay. And into NP0, which you have calculated. Okay. Similar way, when you go to NP2, it will be NP1 into M divided by 2. Okay. If you go to NP3, it will be NP2 into M divided by 3. So on and so forth till you come to the last. Okay. So these I'll rub it off. So this is what is fitting of your Poisson distribution. Okay. So this is pretty simple. Actually, it's not at all difficult. If you have really seen, we have used the same commands as we did in the last session also. So only the thing what is important here is to know the concept correctly, to know the steps correctly. And for this, you have to go to your fundamentals and they should be very, very clear. Okay. So this is about demonstration of normal distribution fitting. It's testing as well as hypothesis testing as well as the Poisson fitting. Now what is to be done next is we will send you the problem sheets, that is your assignment sheets for each of the division and the batch as well. By individual teachers will send it to you through mail or to Google Classroom or through VOLP. You have to solve it in Excel. Okay. And you can consolidate the answer properly, neatly, clean, and you can submit it in a PDF format. Do not directly submit the Excel sheets. Okay, fine. So that's all about this particular practical.